Okay, today we're wrestling with a really big question, one that kind of gets right to the heart of things. Can intelligence truly define itself?
Mhm. It's fundamental.
Yeah, it really challenges our assumptions, about our own minds, consciousness, even maybe reality itself.
Absolutely.
So for this deep dive, we're looking at a piece by Mir H.S. Quadri called Can Intelligence Define Itself?
A very thought-provoking read.
It is. And our goal here is to explore why intelligence might have these surprising uh, inherent limits in defining itself. And, what does that actually imply for you and your world?
Right. Where do we go from there?
Exactly. So let's start with something familiar, something we use all the time. Understanding.
Yep.
Like we say, oh yeah, I understand how this coffee mug works, or I understand that idea, but if you really try to pin it down, what is understanding?
Yeah, what's actually happening there?
What's the mechanism? How do you perceive, say, a coffee mug as a coffee mug and not just like random shapes and colors?
And that's exactly where the author starts. They offer this really interesting definition. Basically, to understand is to cohere, and to cohere is to conceptualize.
Okay, unpack that a bit. Cohering, conceptualize it.
Right. So understanding the coffee mug means the concept of it kind of fits together neatly in your mind. It coheres.
Ah,
And
got
it's
it.
not just one big flash of understanding. It's built up from what the author calls microcoherences.
Microcoherences.
Yeah, like the concept of coffee, the concept of mug, these smaller bits of understanding, these concepts, they fit together, they cohere.
And that forms the bigger concept, the understanding of coffee mug.
Exactly, you got it. That's how you see it and understand it.
Okay, so understanding is coherence, built from concepts. And this leads to, I think, three key points the author makes.
Yes, three main takeaways from this perspective.
The first is that our own intelligence interacts with something in the world, right? An inherent intelligibility.
Right. The world itself has to be understandable in a
Yeah.
way. That interaction allows conceptualization.
Okay. And second, that conceptualizing creates the coherence, which we experience as understanding.
You're right.
But the third point, this is where it gets really interesting. Coherence, especially for abstract stuff, it's self-referential.
That's the crucial bit. Yes, self-referential, meaning our understanding can't fully explain itself from within its own framework.
So the system can't define the system?
Precisely.
Yeah.
And that's the bottom line. Intelligence, based on this coherence model, cannot fully define itself.
Wow. Okay.
And that self-referential loop, that's the central problem, the thread we're going to follow here.
It's like trying to lift yourself up by your own bootstraps, like you said. You're stuck inside.
Exactly. You can't get that final external perspective from purely internal means.
It sounds a bit philosophical, maybe even like a dead end, this loop. But you mentioned this connects to consciousness studies, to qualia.
It does, very strongly. Qualia, or the problem of perception, deals with our subjective experience.
Like the redness of red or the actual taste of coffee.
Precisely. Those raw feelings, the what it's like aspect of experience. We perceive the coffee mug, we have that experience, because we conceptualize it.
Right.
But how do we get from the raw data photons hitting our eyes, the texture on our fingers? How does that become the unified, conscious experience of a coffee mug?
That leap.
Yeah,
How does consciousness happen?
that's the mystery. And it ties right back into coherence and its limits.
And to help visualize this, the author uses the homunculus argument.
Yeah, it's an old idea, technically an informal fallacy, but it illustrates the point really well.
Okay, lay it out for us.
So imagine there's a tiny little person, a homunculus, inside your brain.
Okay, like a little controller.
Sort of. Its job is to look at all the sensory data coming in and
Right.
put it together, conceptualize it, so you perceive the world.
You're right. Makes sense, kind of.
But then you have to ask, how does that little guy perceive things? How does the homunculus see the data it's getting?
Oh.
Yeah. It would need its own, even tinier homunculus inside its brain to do the perceiving for it.
And that one would need another one.
And another, all the way down. It's an infinite regress.
Homunculus 1, homunculus 2, homunculus n. So what's the point here? What does this infinite regress tell us?
It tells us that this kind of explanation doesn't actually explain anything fundamental about consciousness or qualia.
Because you never reach the source.
Exactly. No matter how many little guys you imagine, you haven't actually defined how the first act of perception or conceptualization happens. You're just pushing the problem back endlessly.
You're stuck in that loop again, using the thing you're trying to explain as part of the explanation.
Precisely. The definition remains incomplete because of that inherent loop.
Okay, that's fascinating. And it's wild how this philosophical problem finds echoes in Well, in mathematics, you mentioned Kurt Gödel.
Yes, Gödel. His work in the 1930s, specifically his incompleteness theorems from 1931, absolutely shook the foundations of mathematics and logic.
Shook them how? What did he find?
Well, putting it simply, Gödel discovered that any formal system that's powerful enough to describe basic arithmetic, well, it can't be both complete and consistent.
Meaning?
Meaning, there will always be statements within that system that are true, but you simply cannot prove them using the rules of that same system. The system has inherent limits to what it can demonstrate about itself.
Wow. Okay, the source gives a kind of non-math example, right? The sentence.
Ah, yes, the liar paradox variation. This statement cannot be proven.
Right. So walk us through that. If you try to figure out if it's true or false,
Okay, possibility one. Let's say the statement can be proven.
then it must be true.
Well, no. If it can be proven, but the statement itself says it cannot be proven, then the statement must be false.
Okay. Contradiction.
Right. So possibility two. Let's say the statement cannot be proven.
Well, then the statement cannot be proven is actually true.
Exactly. It's true, but unprovable within the system of logic we're using.
So it's a closed loop that gives a result it's true, but it can't demonstrate its own truthfulness from within.
Precisely. And that's the essence of Gödel's first incompleteness theorem. There are true statements that are unprovable within the system.
And there was a second theorem, too.
Yes. The second incompleteness theorem basically says that a consistent system like arithmetic cannot prove its own consistency from within itself. It can't vouch for its own reliability using only its own rules.
So even in pure logic and math, systems have these fundamental limits on self-description and self-proof.
Correct. They can't fully encompass themselves.
Which really makes you think, if mathematics faces this, what about our own intelligence? Which is, let's face it, way messier and more complex than formal logic.
That's the connection the author draws. If even these rigorous systems have limits, it strongly suggests our own intelligence likely does too.
So let's try and bring all these threads together now. We have intelligence, understanding its coherence, conceptualization, these self-referential loops in perception, and logic.
Yeah.
What's the bigger picture? What does this all mean?
Well, the implications laid out in the source are pretty significant. First, as we've hammered home, intelligence can't fully define itself because it's essentially an internally consistent closed-loop system.
Right.
But, and this is key, it's a closed loop within a larger system, a larger reality, if you will, that possesses its own inherent intelligibility.
Okay, so intelligence isn't operating in a void.
Exactly not. Which leads to the second point.
Hmm.
Coherence isn't just something intelligence does on its own. The author calls it a game of two.
Game of two.
Meaning you need both the intelligent agent, for example, and the inherent intelligibility of the environment, the system we're in. Intelligence alone can't just make up reality or conceptualize things from nothing.
Because that would lead back to the infinite regress problem, like the homunculus.
Precisely. If intelligence alone created the intelligibility, you'd need an intelligence to create that intelligence's intelligibility and so on. You need both the observer and the observable structure.
So back to the coffee mug.
Right. We understand the coffee mug as a coffee mug because we have intelligence, and also because the mug exists within a physical system that has its own consistent properties and laws, its own intelligibility.
Which challenges some philosophical ideas, like idealism.
It does. Idealism often suggests reality is primarily or entirely mental, created by the mind. This perspective argues against that, suggesting reality or experience isn't just created in our heads.
Instead, our experience, our qualia,
Is the result of this interaction, this coherence between an intelligent agent and a system that is itself intelligible. It emerges from that relationship.
Okay, that paints a very different picture of our place in things, not just creators of our reality, but participants in a coherent exchange with it.
Exactly.
So wrapping this up, if intelligence, our own minds, can't fully define or understand itself from within, what does that mean? What are the big takeaways for us, maybe thinking about AI or consciousness?
Well, it definitely raises a profound question for you, the listener, to ponder. If our own intelligence has these built-in limits for self-understanding,
Yeah.
how should that affect our quest to, say, fully map consciousness? Or our ambitions to create truly self-aware artificial intelligence? Does this limitation change how we see the very nature of reality and our ability to grasp it?
Does it mean some things are just fundamentally beyond our complete grasp because we're part of the system we're trying to grasp?
It certainly suggests there might be boundaries defined by the very nature of intelligence itself,
Yeah.
something to really chew on.